Welcome back to the Acorn Land Lab Off-Grid Overview course. Today we're talking about modern energy issues. So we're entering into a new chapter. We're talking about energy. We always start the chapters talking about the current issues that we're solving for. And almost all these issues revolve around centralized systems that have led to very brittle conditions, whether it's centralized big ag and food production, centralized housing with cheaply made mass-produced homes, and now we're talking about centralized energy. You'll see the pattern throughout this course. We talk about the issues that are very tightly bound to central systems, then we talk about solutions that are very distributed and decentralized. So that pattern does not break at all for the modern energy issue landscape. We are addicted to cheap energy here in America, and we've gotten so bound to cheap energy, our systems don't run without it. You can look back over a lot of the military conflicts over the last few decades, and it's pretty clear to see that we have gone abroad to secure energy resources in past conflicts, which really shouldn't be the case. There are so many avenues for energy we could be pursuing for local, clean, sustainable, low-impact living to just make a better quality of life for all of us. We should not be having to fund a mega military to go abroad for energy. There are so many creative ways we can produce the energy we need for low-impact, slow, local living if we get creative. So we're going to talk about the issues first, then dive into those creative energy solutions. Many people simply won't change the way they live to be sustainable. And I understand that. If you look at Maslow's pyramid of needs, most people are just trying to pay the bills, put food on the table, have a little bit of time with family, and they just trying to stay employed, keep the job going to pay the lights. Once you've got your basic needs met, then it's a lot easier to care about things like sustainability. But even then, so many people are stuck on a hamster wheel with work. They're just trying to get through the week, which is terrible for people, terrible for the environment. The foot that I like to lead on with a lot of this off-grid stuff, especially energy, is affordability. You can't always appeal to people talking about sustainability first. So we like to look at sustainability as a byproduct of affordable local living, because it truly is. So as far as energy goes, energy is getting more and more expensive and will continue to get more and more expensive. If you research, and I'll put links below, the easy oil reserves have been tapped and depleted. Now, there's plenty more oil to mine out there and to drill for. Mine might not be the right word, but there's plenty of oil to drill for and extract through methods like fracking. And frankly, I'm thankful for oil. It's the highest quality energy source we have. And when used properly, it's phenomenal for powering heavy equipment to create new ponds and do earth like terraforming and landscaping for permaculture designs. But the way that we use that resource today is incredibly wasteful. You know, people drive an hour or 2 hours to go, to a restaurant. Folks are driving all the time for trivial errands and needs. Our car culture and suburban landscape requires us to hop in the car daily. So it's not that oil is evil, it's the way that we use it is terrible. We use too much of it, we're not using it wisely, and a lot of the practices around that resource are highly unethical. So oil is an amazing resource to be used sparingly. Because we've tapped out the easy reserves, we're going to continue to have to use novel methods like fracking, which lead to massive potential pollution in groundwater and leading to other issues with folks that live near those fracking sites. Because the easy oil has been sucked up, it's going to continue to get more and more expensive to pull what is down there out. And the same can be said for other types of fuel as well. We're going through a natural gas boom in the US, but other parts of the world don't have easy access to reserves like that. I personally would love to be able to source all my energy needs as locally as possible through wood with biomass and through biogas through methane digesters and through solar power. There's no silver bullet, but the key to off-grid living is going to be diversity in energy solutions. So let's talk numbers, because people care about affordability and things are getting more expensive. We as Americans spend a significant portion of our income on electricity and gas. Annual energy expenses are weighing more and more on households. In 2020, the US spent $1 trillion on energy, 1 trillion with a T. That's over $3,000 per person per year on energy costs. Not that it would power all your needs, but $3,000 can buy you a pretty awesome solar generator system. Not that you'd be buying one every single year. $3,000 can buy you 2 methane digesters, maybe even 3. $3,000, you can build your own wood gasifier. Imagine if every year you worked on a new local energy system rather than just paying out to the electrical company and the gas companies. So we spend a fortune on energy, and it's only going to get more expensive, especially as global conflict ramps up. What's happening in Russia and Ukraine right now? That is only going to exacerbate oil prices further. What's happening with China and Taiwan could do the same. So as the war machine kicks in, energy prices will continue to rise. So inefficiency and waste. That's one of our biggest issues today. Our modern energy systems suffer from huge inefficiencies during generation, transmission, and distribution. We get a lot of our power here in Georgia from coal and nuclear, and you've got to send that power over hundreds of miles to its destination. You lose a lot of power in that transmission. Our homes are built so inefficiently, they require massive amounts of energy to heat and cool them. So the biggest hack to off-grid living is building much, much smaller, insulating incredibly well, and building very efficient homes that are aimed southwards towards the sun, are properly shaded during the summer, and just require a fraction of the energy needs. It is misguided to think you can take a suburban home, as massive and inefficient as it is, and throw up a ton of solar panels and now you're sustainable. You want to use as few solar panels as possible. The process for making solar panels is not clean. It's fairly polluting, it's very carbon intensive. Solar panels are great, and I think they're fantastic, but you want to use as few of them as possible. So other energy issues today, our infrastructure is aging and brittle. Everyone loves to build new stuff. Nobody likes taking care of old stuff. We're going to be spending massive amounts of money to fix the current existing infrastructure. And I've read some studies that say we have as much infrastructure in the US now as we ever will, because we'll be rolling back plumbing, roads, electrical networks, because we can't afford to take care of everything we have currently. So infrastructure is aging. The entire American system is dependent on fossil fuels, primarily transportation, but the power plants run on coal. You're trying to source all this from distant places, when if we simply moved around less, we can have a high quality life like David Holmgren in Australia on his Meliadora 2-acre homestead. He uses a few solar panels, they're using biomass and wood for heating, passive solar, and they're growing what they need on site. When you produce what you need on site, you don't need massive amounts of energy to be moving all over the place and trucking goods everywhere. The biggest thing that bothers me about our dependency on fossil fuels is how dependent we are on these massive companies, with the prices continuing to rise. And then, of course, there's the pollution aspect. Centralized control. Modern energy grids rely on centralized control and distribution. You're not in control of the pricing. You're not in control of the blackouts or brownouts. We're seeing the grid continue to crack and crumble. More and more states are having intermittent power failure and brownouts that are intentional, and then blackouts. You can think about the winter storm Texas experienced and the people that suffered not having electricity. Lack of resilience. With a grid that's so brittle and broken, it doesn't come online quickly after natural disasters. And as we build more and more homes, and as the storms continue to roll in more frequently with more power, there will continue to be bigger issues around lack of resilience when power grids are knocked out. We talked about environmental impact, the greenhouse gases and the pollutants. The acid rain that occurs from coal plants burning off, all the emissions that result in more toxic contaminants in the rain, whether it's mercury or other pollutants. Between acid rain, pollution, and smog, there's plenty of reasons to want to get away from these giant centralized fossil fuel plants. But the biggest thing for me is affordability. If you've got a great combination of solar, biomass, biogas, passive heating, you don't need to be paying through the nose for these legacy energy systems. What else have we missed? We talked about geopolitical dependencies. You're better off when you're not depending on some foreign source for energy. That's pretty much it in terms of our modern energy issues. It's very expensive and it's getting more expensive. The infrastructure is brittle, it's breaking, it's very polluting. You don't control it. It's highly centralized control. Current energy usage leads to more military conflict abroad. You're just going to have to work harder over the course of your life to pay for expensive energy. I don't want to have to work for the entirety of my life just to pay to heat a massive home in the suburbs in the winter and to cool it in the summer. So, next things you can do. Make a list of all the electronics that you use. What are all the appliances that you use? Which ones can you actually ditch? Because some of the most energy intensive appliances we use are the ones we actually don't need. You can go off grid very easily if you drop the clothes dryer, if you drop the dishwasher, if you use biomass for heating your home and you have a very tiny AC unit. Anything that heats and cools uses massive amounts of power. Lights, fans, electronics like laptops, cameras, phones, they don't use much power at all. You can power that from solar very simply, very affordably. What uses a lot of power is anything that heats and cools. So if you can find alternative energy systems for heating and cooling, you can go off grid very easily. So make a list of all the electronics you use. What do you have to have? What can you give up? How much solar would you need to power all that? And in a video coming up, we'll talk about solar power, computing how much you need to power what appliances you rely on. What items would you be okay giving up? How could you begin to use biomass for heating, biogas for cooking, direct solar, sunlight, for cooking and heating water? The key to going off grid is a diversity of energy solutions. If you have a diversity, you've got resiliency, you've got redundancy, you've got backup options. And many of them, once you get them set up, are free. You're not paying for utilities. Today we're talking about biogas, digesters, and methane. Our home biogas methane digester is hands down my favorite system in our Acorn Land Lab. It truly is like magic. It's a giant tank of water, basically, with a pouch on the top for collecting methane. You set it up by mixing together cow manure and water. That gives all the liquid the methanogens. The methanogens, the microbes, the bacteria, they are the magic that converts food waste from water in that aqueous environment to little bubbles of methane that bubble up and then are trapped, and then you can siphon that off to a grill top for cooking food up to 2 hours per day. That's on the small home biogas system. More hours per day on the big system. So you're getting rid of food waste and manure going to the methane digester. You're getting free cooking fuel daily, and then because you continue to put material in there bit by bit, you don't want to exceed the daily limit of a few liters, and you put more water in. All that water and the digested material has to go somewhere. So it comes out of a pipe into a 5-gallon bucket. Then you've got liquid fertilizer for your garden. So you take garbage, you take food waste, put it in the digester. You're getting gallons of free liquid fertilizer per month. You're getting hours and hours of free cooking fuel. And I really almost didn't believe it when I read about the system, but then we purchased our first one. We've got one at my house and one at the Acorn Land Lab. We're about to install one at the off-grid micro cabin. And it takes 2 weeks to set up and for the methane to slowly fill and bubble up. But that night when I turned on the burner and the blue flame erupted out, it was like magic. You were creating energy out of garbage. So today's talk is all about biogas, digesters, and methane. This biogas system is dual purpose. Actually, it's triple purpose. It's taking in waste, it's creating liquid fertilizer, it's creating energy for cooking. I love the combination of the home biogas system for cooking at night or cooking on cloudy days, and then the solar ovens for cooking on sunny days. It's a great combination to be able to cook with different systems. So I'll make scrambled eggs from the backyard in the home biogas system. We've cooked steaks, pork chops. We cook vegetables. We cook a lot of our local produce using home biogas. It works just like a propane grill, but I don't pay for propane anymore. So the system will pay for itself after a few years, hands down. The coolest part about this system beyond cooking and fertilizing is you can use it as an above ground septic tank. Home Biogas manufactures a ceramic flush toilet that connects to the home biogas system. So if you're in an off-grid cabin, if you're in a tiny home, you can connect that toilet apparatus with a pipe to the home biogas system. It's got a push pump to flush. It uses 1/10 the water of a traditional toilet. Now, there's a few caveats. You would not be using that effluent or liquid fertilizer. You would not be using that liquid fertilizer for garden vegetables. That could have a contamination and make you sick because there's human waste. You would run the pipe from the home biogas digester to a leach field, just like a septic tank field. You could make a gravel leach field with pipes, but many people just make a wood chip leach field. They'll dig trenches, put wood chips in, and one of the best things you could do is plant comfrey to be able to grow and then chop that down, use as a fertilizer component in your compost bins. Or plant berries, woody stemmed plants or fruit trees, because then the contamination, human waste won't contaminate the fruits like it would leafy greens. So planting a food forest at the end of your methane digester is a home run because you're utilizing all those nutrients. And you could just have a bamboo patch or something else for biomass production. But the point is, you let those nutrients go back into the natural carbon cycle and produce more plants. Methane digesters are pretty simple when you boil them down. You've got a container, you fill it with water and manure. It could be pig manure, cow manure, those are the primary ones for methanogens. Chicken manure has a little bit too much nitrogen and is considered hot, so you want to use that sparingly. But you put the manure in with the water, mix that together, you've got a slurry, that creates the methanogen mix. Then daily you're putting food waste in, or you could put more manure if you've got it. For instance, I put the manure of my Kuni pigs into the home biogas digester to utilize that for liquid fertilizer and for methane production. All that's in there, and then the heat of the sun allows the microbes to do their thing. The methane digester needs an average temperature of 68 degrees Fahrenheit to operate properly. It can go lower than that in the evenings as long as it's going higher in the daytime to average out to 68 degrees Fahrenheit. Methane digesters are great for warm and temperate climates. You can put a greenhouse around it to extend the season it operates. But if you're far up north and you're going below 68 degrees Fahrenheit consistently, you're going to have to get very creative to use a methane digester. One of the solutions we've been dreaming up is having your methane digester in a greenhouse and building a rocket mass heater that uses very little wood fuel to keep the environment working during wintertime. Here in Georgia, we just pop a greenhouse on it and it's good to go all year round. Beyond biogas production for cooking fuel, beyond waste processing, beyond the fertilizer being created, biogas can even be used to power engines. There's a farm in England, I'll put a link below, that uses biogas from their cattle operation for powering their tractors. There are methane-powered tractors out there, which to me is mind-blowing. You can power an engine if you have enough methane, as it is combustible. So biogas is a resource that people are tapping into more and more. If you were to go to a landfill, many landfills now have pipes that are bored into them because all the food waste and the organic material in landfills is decomposing, turning to methane, which could create flares, or it escapes into the atmosphere, and methane is a very potent warming greenhouse gas, far more than CO2. I believe methane is 80 times more potent than CO2. I'll double check that and put that data down below. Landfills are wising up and they're tapping into that resource, and they'll often use it to generate electricity or ship that methane off for some other purpose. I don't think landfills should ever have to do that though. If we as consumers are using, not just consumers, if we as consumers and producers are using methane digesters right where we are, we shouldn't have to ship our food waste out with the garbage. Keep our organic material right where we are at restaurants and homes. Home Biogas makes a commercial-sized methane digester for hotels and for restaurants to take all their food waste and turn it into energy for heating, water, and other purposes. Biogas systems replace traditional fuels like wood or charcoal, which reduces indoor air pollution. Home biogas systems are a novelty and really cool for off-grid living here in the States. But in developing countries, over in Africa, home biogas systems, they could extend the lives of the people using them because they're reducing the particulate matter in people's homes when people are burning wood, charcoal, or animal manure, dried cow pies, to cook with. So home biogas could actually save people's lives if it's being deployed in areas where they're using other more primitive ways of cooking. There are two other companies I'm aware of that build home biogas systems. Puxin, P-U-X-I-N in China, I believe it is, and then B Energy in Germany. They're producing home biogas systems. Well, not home biogas, that's the brand coming out of Israel. B Energy is producing biogas systems for use in Africa, which is creating an independent energy market. Folks can brew their own biogas using their methane digesters and then put it in these big pouches that you can walk from village to village with and sell cooking fuel, which I think is amazing. Anaerobic digesters, methane digesters, operate through the anaerobic process. Anaerobic digestion occurs in an oxygen-free environment within the digester. Microorganisms break down organic matter, releasing methane and carbon dioxide. When you cook on home biogas, it doesn't smell any different than cooking with propane. You are reducing greenhouse gas emissions, you are preventing food going to the landfill, which saves fuel for the garbage trucks. Because for us, we produce hundreds of pounds of material for the home biogas digester every year. You get the liquid fertilizer. There are just so many benefits to this. And the toilet and the home biogas combo cost $1,500. A septic tank system can cost $15,000. So you're paying a tenth the cost for an off-grid sanitation system, which is truly amazing. So I believe that methane digesters and home biogas are truly a cornerstone for sustainable off-grid living. There are too many benefits to ignore them. And many people get grossed out by composting toilets or sawdust toilets. And I get it. You have to get used to that, even though they work very elegantly and there's nothing gross about them at all. The flush toilet from home biogas is a great stepping stone for people that are not quite ready for a composting toilet and they want a very hands-free system to operate. All right. Your next actions. Research the home biogas systems. I'll have links down below. Check out B Energy and the Puxin systems as well. Look into the DIY biogas systems. You can make your own biogas system from an IBC tank and some PVC piping. It's really not that difficult. If you live in an apartment, take your food scraps somewhere, see if there's a methane digester you can take your food scraps to. If you're in the suburbs, consider buying your first home biogas system. And if you're in a rural area, you might even have farms near you that are using home biogas at a much larger scale. So methane digesters and biogas are a phenomenal way of managing and using your resources wisely. Last note, this technology is not new. It's been used in India for a long, long time, hundreds of years. I believe the first methane digester was created in 1859, but maybe even prior. I'm going to research that and put the link down below as well. Today we're talking about energy still, but we're specifically talking about the source of all energy. Well, I believe it's just about all energy in our solar system, the sun. Ultimately, even our oil reserves come from the sun, since it's the remains of algae and other life forms that were compressed and other microbiota thousands and thousands, hundreds of thousands, millions of years ago. However long ago, all that material was produced from sunlight. Solar is at the source of off-grid living, utilizing solar directly. When we're utilizing fossil fuels, whether it's coal or oil, we have to rely on middlemen companies to extract and then deliver that product to us. And that puts us at a disadvantage because we're not able to care for our own needs as well. Where prior to fossil fuels, communities all over the globe relied on direct solar energy for drying products in the sun, whether it's dehydrating food, for growing biomass, for wood fires and stoves. Wind power. Wind power ultimately comes from the sun as well. It's the sun's temperatures, it's the temperature of the sunlight that creates the differentials for the wind to flow across the surface of the earth. It's the heat of the sun that helps evaporate the water to move rain inland, to have water moving through rivers to power hydro. So whether it's wind, hydro, solar power, even looking back to fossil fuels, all that energy ultimately comes from the sun's energy. So in off-grid systems, we want to directly tap into that. We don't want to go through middlemen for coal or for other sources of fossil fuels like natural gas or gasoline. We at least want to reduce our dependency on those sources. So today we're going to talk about photovoltaics, solar hot water, solar passive heating, and solar cooking. So we will kind of do those in reverse order. Solar cooking. We've talked about this a little bit. We love the GoSun ovens with the parabolic mirror and the vacuum glass tube for solar cooking. That glass tube can get temps of up to 500 degrees Fahrenheit to cook your food after 20 minutes or so. So we're using nothing but sunlight. It's fuel free for cooking our food. And there's many different types of solar ovens available. Heating water with solar. We do not do that here in the States. There was a push to do that back, I believe, in the 70s. I think Jimmy Carter had some solar hot water heaters on top of the White House. From what I've read, when Reagan came into office, he ripped them out. We've never needed to rely on solar hot water in the US because energy's always been so cheap. It's just cheaper in the short term to install a gas hot water heater tank and pay for gas every month. That will likely not be the case in the coming years. So in Israel, 90% of homes rely on solar hot water heaters. It's a tank that's got a series of vacuum glass tubes The glass tubes from solar hot water heaters actually inspired the Ghost Sun solar oven for cooking food. The same principle applies. Water flows from the cold water source into the solar hot water heater, and then the water is circulating through those glass pipes, heating up, and it moves up into the holding tank with hot water as the hot water rises and the cool water sinks to the bottom of those pipes. So solar hot water heating is very common in a number of countries. It's more common in areas in the Caribbean, it's common in Israel. It's not common here in the States because we've had so much cheap energy for so long. But it's high time we make solar hot water heaters a common feature in our homes, whether you're in an urban area in a city, the suburbs, an off-grid rural zone. Part of the problem of having a system that's not utilized is you don't have economies of scale. If we had millions of people using solar hot water, those systems would be way cheaper because we'd be mass producing them. They're a novelty piece. So solar hot water heaters cost us thousands and thousands of dollars today. There are some in the hundreds. And I'll have links below to vendors to buy solar hot water heaters from. Sunbank is one of them. There's another group in Alabama that I'll have a link to as well. If you have factories spun up to make these for millions of people, the price goes way down. In the US, the demand is not there yet, but in Israel and in other countries where these are common products, these are very affordable. These are often more affordable than a gas heater. So solar cooking, heating your water through solar power, are ways that we can totally bypass the need for fossil fuels. We go straight to the sun source. And I like these technologies because they are safe, they are slow, they are gentle. There's nothing explosive about these technologies like any type of gas or gas-powered technology. Having a gas line in your home is not particularly safe. Now, the methane digester gas line is very safe because it's not pressurized. If there's a hole in the methane digester, the gas will just escape into the atmosphere and that's that. There's no potential for massive explosion. The sun is used directly for heating methane digesters. Without the sun's heat and warmth, the methane digester microbiome wouldn't be able to flourish. All those microbes need sunlight and heat to do what they do. Using sunlight for solar hot water or solar water distillation. When you are able to build a solar water distiller, you can purify water by heating up the water to where it evaporates, it condenses on a condensing board, and then trickles down into a holding area where your purified water is. Solar dryers. I've seen memes that are hilarious that show a solar clothes dryer. It's just a line. It's just a string for hanging your clothes on, clothesline. But it works, especially in an area that's not too humid. Here in the South, that can be trickier because it's so humid here. But out west and in the various parts of other countries globally where you don't have as much humidity, ditching the clothes dryer is a great way of reducing your energy needs. So using solar dryers for clothing, but not just clothing, using it to dehydrate food. Paul Wheaton at Wheaton Labs has some great solar food dehydrators. I'll try to link to that down below as well. Solar passive design. Our homes in the Northern Hemisphere should be intelligently built and aimed towards the south with windows and roof overhangs that minimize heat in the summer and maximize heat in the winter. It takes a little bit more planning and forethought, but we could save massive amounts of energy by designing our homes more intelligently. Our homes shouldn't just be plopped down all surrounding the road based on a subdivision design. That's essentially just worshiping the car model. Homes are designed around roads today, which is ridiculous. Roads are built for cars, cars are built for profit. If our homes were oriented properly, we could leverage so many energy savings through passive design. Simply aiming our homes and designing overhangs and window systems properly can help provide more free heat and more free cooling in the winter and summer. Solar-powered water pumps. Now this is where photovoltaics do come in. There are more pumps available for small farmers, especially in developing countries, but pumps that are solar-powered, they use a flywheel to generate kinetic energy and keep the water moving. And it's powered by a solar panel. So you can see the diversity of options here from the sun itself. It makes way more sense to use a solar hot water heater, a methane digester, a solar oven, a solar dryer, than to have nothing but a ton of solar panels powering all those systems using electricity. Electricity is such a high value energy source, we want to use it sparingly because solar panels are very expensive and the process to make them still is toxic. All right, here we go. Now we're at solar panels, photovoltaics. So You're familiar with photovoltaics, solar panels. They've been around since the 70s. They continue to drop in price. More and more homes are having them installed. The trick is to use them properly. It really does not make much sense to have a massive bank of very expensive solar panels and very expensive batteries to power your very large suburban home and all of its appliances. If you've got the money to do it, sure, but it's not affordable. It's not affordable for the average person, and it's really not that sustainable when you look at replacing your solar panels every 25 years. Many people replace them more frequently. The key to photovoltaics is using the panels sparingly just for what you need. So photovoltaic panels convert sunlight directly into electricity. We've got solar panels in our land lab and back at my house. The basic anatomy of a solar panel system are the solar panels, which are generating power ranging between 12 to 24 volts. Then the solar panels are connected to the charge controller, which makes sure you're not overcharging your batteries or over depleting your batteries when you're using power. So you've got solar panels, charge controller, battery bank, and then inverter, which pulls power from the battery bank and inverts it from 12 volt power DC to typically 120 volt power AC, alternating current. Our homes in North America use 120 volt AC power. Most of your appliances are going to use that. So photovoltaics are how you create electricity for powering your lights, your fans, your computer, your cell phone, and often a small air conditioning unit or charging power tools. So let's talk numbers. Anticipate spending around $5,000 to $18,000 for a solar panel system to power your off-grid environment. You can get away with spending as little as $1,000 for a few small panels and a solar generator, but you're going to have to be very sparing in how you use your energy. I've got a $1,200 Delta EcoFlow lithium-ion battery. It's an all-in-one package. It's got the charge controller, the inverter, and the batteries all in one. And then I've got 400 watts of solar panels on my shed. That powers my electric mower, my other electric power tools, my weed whacker, my chainsaw. That is a great system, but we don't rely on it fully for living. If I wanted to power a small air conditioning unit, if I wanted to power a table saw, if I wanted to power lights and fans and laptops and the family using multiple things at once, I would need a larger solar panel system than just the 400 watts. So before we get too deep, let's talk about measurement for solar panels. Electrical consumption is typically measured in watts or kilowatts and kilowatt hours. That was one of the trickiest things for me to wrap my mind around when I first started researching solar panels, and I think it's what trips up many people. So let's talk really quick about what is a kilowatt, what is a kilowatt hour, and how do we translate that into our practical needs. So a kilowatt, kilo means 1,000, and then a watt is the unit of electricity. A kilowatt hour is when you're using 1,000 watts of power over the course of 1 hour. So we've got 60 watt light bulbs. A 60 watt light bulb would use 60 watts over the course of an hour to produce the light that it's producing. So a few other examples for you. 1 kilowatt hour of electricity is enough to watch television for 10 hours. So if you have 1 kilowatt hour of electricity, you can watch TV for 10 hours. You could vacuum for 1 hour with a typical vacuum. You could wash 12 pounds of laundry. You could work on a computer for 5 to 10 hours. I've got about a 1 kilowatt hour lithium battery for my Delta EcoFlow setup. That would power a small window AC unit for about 1 to 2 hours. Cooling and heating takes a ton of energy. It could probably power a small electric heater for about an hour or two. So you can see very quickly 1 kilowatt hour battery capacity is not enough to supply a family's needs, especially heating and cooling. Now, if you're just a single person living in a very slim off-grid environment, it could totally provide the basic electrical needs for lighting, computer, a fan. So you're going to want to determine how many appliances do I need to run to live a life that I'm comfortable with? What appliances can I get rid of? How many watts per hour does each appliance use? The typical American family and household uses 30 kilowatt hours of electricity per day. That's about 900 kilowatt hours per month. So if the typical family is using 30 kilowatt hours per day, you can go ahead and imagine if you're living off grid, you'll probably be using half of that or less, unless you install a mega solar panel system, which we would not recommend. So there are folks like David Holmgren that are getting by with 4, 5, 6 kilowatt hours per day. They're very sparing and they've got their systems dialed in. So I would not expect for someone living in North America, unless you're just a real hardcore survivalist type, to suddenly be using less than 4 or 5 kilowatt hours of electricity per day. For most of us, we should try to aim for 10 to 20 on the high end. 10 to 15 is more realistic. Let's talk pricing per watt. Solar panels fall in 2 categories: monocrystalline, which are the most efficient and more expensive solar panels, and polycrystalline. Monocrystalline panels typically cost $1 to $1.50 per watt. So we've got a 400 watt solar panel out there, which cost about $400 to buy. Polycrystalline panels cost about 75 cents to $1 per watt. So that's a good way of ballparking solar panel costs. Battery costs vary. The cost of lithium-ion batteries is falling. Lead-acid batteries are very inexpensive. They're just heavier and bulkier. So battery technology is the real key to crack for your solar setup. There are lithium batteries, which are very lightweight, but there are dangers. If they overcharge, they can explode into a fireball. If you have lead-acid batteries, they off-gas. You want to make sure there's good ventilation around lead-acid batteries. They're affordable, they're very heavy and bulky, but they're actually considered to be more eco-friendly than lithium-ion because I believe it's over 95% of all lead-acid batteries are recycled. We have an amazing recycling program in the US to recycle lead-acid batteries. So those are not a bad option to use. There are other types of battery technologies that I'll link to down in the description, but lithium-ion and then lead-acid are the most common types for off-grid living. I am very excited about sodium-ion battery technology. It's an aqueous battery that's non-toxic. It uses salt water, and then it uses various cathode and anode technologies that would have carbon and then other minerals to be able to produce a very large battery that could power your home. A saltwater battery is made out of inexpensive materials. The companies developing them haven't quite cracked the recipe yet, but I think there's tremendous promise in saltwater aqueous batteries, sodium-ion batteries. All right, so using solar electricity wisely is key. In our micro cabin, we're not going to have an electric heater. We will not have an electric hot water heater. There will not be an electric oven. In our micro cabin, to make use of the smallest amount of solar possible, we will only be using solar panels to power light bulbs, fans for cooling, a very small window air conditioning unit, charging laptops, and then power tools. We'll be relying on a wood stove for heating. We'll be relying on passive solar design to make the home more efficient. We'll be relying on methane digesters for cooking fuel, solar ovens for cooking fuel. You see how this landscape is very diverse with all the energy systems. So let's see here. We're not going to go over grid tie because we're talking explicitly off-grid systems. I'm going to link to a series of the turnkey solar panel systems below, like the Delta EcoFlow that we like to use. We have another partner in solar, Continuous Resources. I'll link to their kits below as well. You need less solar than you think if you can leverage all these other energy systems for a diverse set of sun-based, sun-powered systems. All right, let's wrap this up. Next steps for you. Research your energy consumption needs. Start by looking at your power bill. How many kilowatt hours are you using per day? How many appliances are you using? And how many watts per hour do all those appliances utilize? Which ones could you give up? Are you totally dependent on your clothes dryer, your dishwasher, your electric heater? Could you replace those with other systems like the ones that we've listed? What size solar panel system will you need? Can you get by on 400 watts of solar panels? Do you need closer to 1200 watts of solar panels or more? Take a look, start doing the math, become familiar with calculating what appliances do I need, how many panels do I need, how much battery storage do I need. Then you can start to price and size your own solar panel system. I'll have a link to a calculator below to make that easy. Since we're still in the energy chapter, we're going to be talking about biomass for energy. So there are a number of systems that leverage biomass for energy production. Now let's define biomass first. Biomass is an all-encompassing term for woody material, carbon plant material you can burn. Wood chips, sticks, logs, twigs, branches, split logs, non-treated lumber, timber, that's all biomass. Biomass is how humans have heated themselves with fire for thousands and thousands of years. Biomass is one of our oldest forms of energy. It's also one of the most sustainable forms of energy. Unlike oil, trees regrow. Now, biomass is leveraged in unsustainable ways currently. Here in Georgia and much of the Southeast, there are mega monocrop tree farms with pine trees. Those are often chipped up into wood pellets and shipped over to Europe to generate power in power plants. From the little reading I've done, that is really actually not a very sustainable way of going about it. Shipping wood, which is way less energy dense than oil or gas, across the sea to burn in plants in Germany, that is more of a political effort and stunt than it is something that's truly sustainable. These monoculture pine forests, they're technically biomass, but it's not being done in a way that is as sustainable as it could be. So just because it's biomass doesn't mean that it's perfect, doesn't mean that it's totally sustainable. But we're going to dive into the systems that can leverage biomass. There are 3 primary systems we're talking about today. 4 if you include the good old-fashioned campfire fire pit, but that's not one that you're unfamiliar with, so we're going to skip over that. We'll be talking about wood stoves, small wood stoves for tiny cabins, tiny homes, wood stoves that are very efficient, that are able to burn the wood and capture the heat well to heat a 200, 300, 400 square foot zone. We'll be talking about rocket mass heaters. I cannot wait for us to build our first rocket mass heater out on our 7-acre zone near our micro cabin. Paul Wheaton has done a lot of work with rocket mass heaters. They use very little fuel. They capture a ton of heat in the mass, the sand and the rock around the stove and the stovepipe, essentially. And then we'll be talking about combined heat and power, CHP. There are a number of systems that fall under CHP, but it boils down to having an engine, whether it's a combustion engine or a Stirling engine, and then having a fuel source that is biomass. And then from that, you can take the heat to heat water or air from the actual combustion process and burning process, but then you're also powering the engine to generate electricity from biomass. These are all viable options to create heat and energy in the form of electricity or mechanical energy from biomass, from wood. All right, so let's start with wood stoves. There has been a pushback against wood stoves recently in a number of countries, and I'm sure that there are people on both sides of this argument. I, for one, think responsibly managed biomass is an amazing way of heating one's home. There are arguments around the particulates and the issues around burning wood. The stoves continue to get better and better. Wildfires, forest fires, burns have happened for millennia. It's part of the natural cycle. It is not a negative thing for wood smoke to enter the atmosphere. Wood smoke has far less of a negative impact than a lot of the synthetic items that we've been burning, such as various types of petroleum-based products and fuels. So wood stoves are a fabulous way of heating up your yurt, your tiny home, your cabin, your A-frame, your wafati, your earthship, your tiny house. There are many different models of wood stoves. We'll be using one for our micro cabin build, very likely the Dwarf Light wood stove. But these stoves use far less wood than a stove for like a big old farmhouse or a traditional home or structure. So with wood stoves, you can cook on them. You're able to heat a few hundred square feet. You can even apply a thermoelectric generator called a TEG, which is a type of electronic panel that sits on the wood stove pulling heat, and it can generate electrical current. So even with a humble wood stove, if you've got a flat metal side on it, you can put a TEG, thermoelectric generator, and generate some power for charging electronics just from your wood stove, which I think is pretty awesome. I'll link to some TEG technology down below. There are certain fans that utilize TEG technology to blow the hot air from your wood stove to circulate it through your small home. So wood stoves are a phenomenal way of heating, of being able to cook, heat up water for tea or bathing in a small cabin off-grid environment. We'll be posting more content as we start using our own wood stove out at the 7-acre property. We'll likely also install a different model wood stove in our canvas tent, our bell tent, and eventually the tiny house as well on the Acorn Land Lab. So wood stoves are best used with hardwood. When you use softwood like pine, the tar and residue can build up more quickly. But there's not a whole lot more to explore in the wood stove world. I'll just have more reference links down below. Let's move into rocket mass heaters. This is a fascinating concept that's been gaining more steam. A rocket mass heater, and we'll have a diagram below and throw something up on the video as well. A rocket mass heater is effectively a bench, a big, bulky bench made out of cinder blocks, stone, sand, cob. There are many materials, earthen materials you can use to make the rocket mass heater. It sits within your home or within a greenhouse or within a cabin. Now it's not portable. You build it in a fixed location. The rocket mass heater has an entry point where you put twigs, sticks, and small splits of wood. You're not burning logs in a rocket mass heater. It's a very efficient system. You get that fire going, that input pipe moves through the mass. The mass is your battery for power. You might have seen there's new technologies where they're storing solar power or geothermal. Other types of energy are being stored in massive sand batteries. You can use sand and rocks to store energy. It's a low-tech battery. That's what the rocket mass heater is. So you're burning your fuel at the entry point, and when you start the burn, air begins to move through the pipe system of the rocket mass heater. The combustion is occurring as the flames are being pulled into the burn barrel. There is a steel oil drum, essentially, that is flipped upside down over the pipe that comes up through the rocket mass heater. That's where the pyrolysis occurs. Your wood is burning the gas off, and then it's burning the actual carbon structure of the wood. That creates this vortex within the barrel, and as all the hot air, which can be hundreds of degrees, 400, 500, 600 degrees and higher, is blasting out, all that heat is being soaked up by the earthen mass around the pipes. Instead of a traditional wood stove where a lot of your heat is going straight up the pipe and out into the world, by the time the air is blowing out the side of your house in a vent, the air is often cool to the touch, to where most of that heat has been trapped in the mass around the rocket mass heater. So you're using a fraction of the wood that you would in a traditional wood stove with split logs. You're able to just harvest sticks, twigs, small wood splits to make the rocket mass heater work. And you are left with a toasty home, a warm bench area you can set pillows and blankets on, and people often shape the cob or other materials into beautiful artistic patterns. We'll have more photos below. But rocket mass heaters are a concept that seems to just make too much sense. There can be some complications making sure the air is flowing properly. You do not want the air flowing back into your home. Then you'd have smoke, soot, and other contaminants in your home. But rocket mass heaters seem to be an amazing low-tech way of heating a home with very little biomass. So let's make sure we haven't missed anything with rocket mass heaters. They're efficient for heating with wood. There's a high heat transfer because of the insulated chimney, which is that steel barrel. Minimal smoke and emissions. They leverage the natural draft of air heading out of the combustion chamber. There's many different diverse applications: homes, greenhouses, workshops. It's a very sustainable way of heating, and it's got great DIY potential. It's a project you can build. Once again, you'll probably have a hard time zoning it if you're in a metro area, so you'll need to head for a more rural area, or build it in an ADU or some non-permitted structure. Many ADUs have to be permitted as well, so that can be a tricky thing. All right, let's talk about wood gasification. Wood gasification and combined heat and power, CHP, are closely related. Back in the US and Germany during World War II, when there were shortages of diesel and other fuels, there were many different vehicles that were powered by wood gas. When we run our double barrel retort to make biochar in the Acorn Land Lab, we're filling up the inner tank, the inner barrel, with biomass to turn into biochar. Then the outer ring is filled with fuel. When the outer ring burns down, it's baking the wood in the middle. When that wood superheats in the middle, the flammable gases escape, and then those flammable gases burn, further accelerating the cooking process. So the fuel is the outside wood burning totally, and then the gases of the inside wood escaping. That is wood gas or syngas. That is the basic process by which you can run a combustion engine off of wood gas. So if you set up a similar barrel system that is designed to siphon off the wood gas, and we'll have more links to wood gas systems below, you are able to take biomass, take wood, take pellets, wood chips even, superheat them to extract the gas. The gas can then flow into a generator, an internal combustion engine with a few small modifications, and then begin to generate power. There's no gasoline involved. It is simply wood gas that is being moved through the engine to spin the rotor and to then generate electricity from the dynamo. I think that's pretty awesome. That's one of our to-do list projects around here. There's many great resources online that show you how that works. But there's a number of companies that build commercial wood gasifiers. One of my favorite ones that I've been following is made by All Power Labs. They make a system called the Power Pallet. Now, it's an expensive system, but it has the potential to power a number of small homes. It could effectively be a decentralized power plant for a number of small homes. And the byproduct is biochar that you can use in your gardening. So just like the home biogas system, there's no toxic byproducts. The All Power Labs system, and I'll have a link below to them, All Power Labs takes in wood, takes in biomass, is able to then generate electricity and heat for your home heating needs, your hot water needs, generating electricity for your outbuildings, your tiny home, a small village of tiny homes. And then the only byproduct is the biochar and then the emissions from the actual burn process. So All Power Labs is one of the brands that's working on those wood gasifier power systems. We've also got Biogen. They're a smaller company in Ohio. I've researched them a little bit. I'll have a link to their website down below. And then there's a European company called Okefin. Okefin uses Stirling engines in their system and setup. Because there's many European countries that have a lot more shady and clouded days than here in the US, the Okefin system is meant to be a complement to solar power. You've got your photovoltaic panels for sunny days, and then the Okefin system can kick in to keep your home powered when the sun is not shining and the battery systems are not charged from sunlight. The Okefin system takes wood pellets, burns them, that powers a Stirling engine, and then you've got heat and electricity from the Stirling engine and then the burn process. So CHP is a relatively unknown form of generating power from wood products. Wood gasification has been around for a long time, much like home biogas. It's just not heavily utilized. If you're on property with a steady supply of wood, you can absolutely support your heating needs, your water heating needs, biochar needs, all from small and minimal harvests, often of just branches and twigs if you're using a rocket mass heater. So whether you choose to go with a wood stove, combined heat and power with a more advanced system like Okefin or Biogen or All Power Labs, or a homemade rocket mass heater, there are phenomenal options to heat your home with biomass. You're not using natural gas, you're not using electricity coming from a coal plant, you are using biomass. And if the home is very efficient, you don't need to use very much biomass to make it happen. Let's do a quick scan to see if I've missed anything. One of the cool things about the All Power Labs generator, the Power Pallet, is you can utilize waste wood, agricultural residues, or forestry byproducts. There's a lot of waste material out there that can feed into biomass systems. All right, next steps for you. Research All Power Labs. Click the link below, check out their Power Pallet. Try to envision how that Power Pallet could power a number of tiny homes and yurts in a small village. Research Biogen. They make a more residential scale generator. And I know they're a very, very small team, but I'll link to their website down below. Research Paul Wheaton's rocket mass heaters. It's a great DIY project. Look up tiny wood stoves. I'll have a link to them below. These are the models we'll be using for our future projects on the off-grid property. And research Okefin, the European company. I'll have those links below as well. All right, thanks a bunch. I will see you in the next video.